All right, class. So today we're going to do starting chapter 11, and we're going to start going back with circles, but we're going to cover the parts of circles we didn't cover last time. So we're going to start with circumference and area, things you'd be well familiar with based on middle school, and we're going to go and separate these in a little bit more in depth with arc length and sectors, and we'll get to those in a minute. But let's just start back with circumference. Let's review circumference. Circumference is the perimeter of the circle, so how far around it is around the circle. Couple formulas you probably remember is that circumference here is C is equal to pi times the diameter. So C is pi, circumference, C is equal to pi times the diameter. And we're going to leave pi as pi most of the time unless they ask for a decimal answer. Or if you remember, the diameter is equal to 2 times the radius, so either 2 pi r. And I tend to use the 2 pi r more than I use pi times diameter. Just a personal preference in this one because you see radius more often than you see diameter. All right, and so I have a couple of examples here, just some basic ones to go over here. So we want to find the circumference of the first one. So looking at the first one here, we see that the radius is 9 centimeters. So my circumference is equal to 2 pi times 9. And so 2 pi times 9 would be 18 pi, and since it's in centimeters, so it's 18 pi centimeters. And that's an exact value, that's an exact answer, and that's where I want you to leave it. Unless I ask you to change pi, don't change it. Leave pi as pi. Looking at the second one, we have a diameter here is 15 feet. So now we can use the first one, pi times the diameter, and so we get circumference on this one is pi times 15, or basically we can rewrite this as 15 pi feet. And we typically want to put the units if we're given units, just to say what we're dealing with. All right, and the third one in here gives us that the circumference is 20 pi, and we want to find the radius. So we want to use the 2 pi r, and we're going to set it equal to 20 pi. So 20 pi equals 2 pi r, and we got to solve for r. So I'm going to divide both sides by 2 pi. And what we see here is that the pi's cancel out, and 2 goes into 20. 10 times. So R is equal to 10, and since we're in yards, 10 yards. And then just something to kind of think about when you're doing it science class and stuff. If you hear the word revolution, it means basically one time you travel around the circumference. So think about if a tire is revolving or revolves or rotates once, it's how far the circumference. So basically, it moves that distance. That's what one revolution means. We're not going to deal with it much in our class, but that's just for if you do science and everything. All right. So what comes off of circumference? Well, we have what is called arc length. And arc length is basically just taking a fraction or a portion of the circumference. It's instead of the whole thing, which is one circumference, we're going to just take a piece of it. Think about, guys, if you were eating a pizza with crust, not the thin crust, no on that, but a pizza with a normal crust. If you took a slice of the pizza, that crust would be a portion or a arc length of the whole pizza. So we see here we have P, my circle P with AB on the circle, and it creates arc AB. And the length from A to B is what is called the arc length. How long is it, or how far is it from A to B? It's not the degree measure. That's arc measurement. We're talking about arc length. Now, the formula we're going to use for this is a proportion. And we see here it's at arc length over 2 pi r. So that's arc length over the circumference, right? Because I told you it's a portion of the circumference. It's part of the circumference. So arc length over the circumference is equal to the measure of the arc over 360. So it's whatever the measure of the arc over the whole circle. So think about it, guys. It's a proportion. You see, it's a proportion. So you can set it up as that. Another way you could rearrange it is that arc length is equal to the measure of the arc over 360 times the circumference. And if you want to use that, if we're just doing basic arc length, you can use that formula as well. All right, so a couple of examples, and we'll do a few here just to kind of get us in. So here we go. Here's my first one here, and we're looking for what is the length of AB. So I'm going to use the proportion version, but if you want to use regular arc length, you can. We have that the measure of the central angle here is 60 degrees, which means the measure of my arc, the measure of arc AB, is equal to 60 as well. You remember this from previous unit. And then we have my radius here is 8 feet. So we don't know what arc length is, so I'm going to put AL over 2 pi times 8 is equal to 60 over 360. All right, so we can solve this. So arc length, I'm going to just simplify things, equals 16 pi is equal to, well, 60 over 360. The zeros cancel out, and that's 1 over 6. So basically, my arc length, in this case, is equal to 16 pi over 6. And if I reduce that, that's 8 pi over 3. And since we're dealing in feet, that's feet. So there's my answer. And that's an exact value again. I don't need to change the decimals. I don't need to multiply pi. I don't need to divide 8 by 3. That's a really nasty decimal if you start doing it, especially if you don't have a calculator. But that's a perfectly acceptable answer. So my length of AB is 8 pi over 3. And if you use the other formula, you get straight to there as well, so it doesn't matter. All right, so here we go, a couple of different ones. So this time, I'm looking for the arc length of EGF. EGF. So I'm looking for the arc length of the outer one here, the major arc, not the minor arc, which is what's being represented. Though we do know that the measure of EF here is going to be 60 degrees as well, so that means that my measure of arc EGF has to be 300, 60 out of 360. So I can start doing my formula again. I can say my arc length over 2 pi times, in this case, 11, is equal to 300 over 360. So again, I'm going to simplify. Arc length over 22 pi equals 30 over 36, and then they're both divided by 6 ends up being 5 over 6. So now my arc length in this case is equal to 5 times 22, which is 110 pi over 6, because again, I'm multiplying both sides by 22 over pi, or 22 pi, just to cancel out on both sides, just so we see where we're going with this. And then that reduces to 55 pi over 3, and do we have any units to this one? No, so that's what we're just going to leave it as, 55 pi over 3. The next one is that we were given the arc length, but they're asking to find the measure of angle P here, right? We're looking for that angle. So we're looking for the central angle, which we know is equal to the measure of arc AB. So if we can find arc AB, then we can find the measure of angle P. So we're going to do this a little bit in reverse. So I'm going to do this. We know that the arc length is 22 pi over 3. We know the circumference. Well, we know the radius is going to be 2 pi times 11. And then that's going to equal the measure of arc AB over 360. So really, guys, we're solving for a measure of arc AB here. So if you think about it, that's 22 pi over 3 divided by 22 pi. Well, guess what? What does that happen there? Well, we're going to see that sorry about that. The 22 pi are going to cancel out. So that's going to leave me with 1/3 equals the measure of arc AB over 360. Well, then that's an easy one to solve for at this point. Is that we're going to multiply both sides by 360. And that's 120 equals the measure of arc AB. So the measure of angle P is 120 as well. So there's my answer. All right, now we can start getting into some composite figures here. So we can start mixing and matching different figures. So in this case, we want you to find the area of the shaded region. So we're looking for the perimeter of this part. I said area, I meant perimeter. All of this is like bridge type thingy here. The rectangle with the circle cut out of it. So with this one, right, we need to figure out the perimeter. So here's the thing, we got a rectangle. We know that all the way across here is 8, which pretty much tells me that up here is 8 as well, yes? And then we know this side's 5, so we know this side over here has to be 5. So right now, we know 3 sides of my perimeter are going to be 8, 5, and 5. What we don't know is that last part. Now, we know this is not a full circle, but it's a half a circle. So if you think about it, if my diameter here is 8, that means my radius is 4. And if we're doing half a circle, well, the circumference is 2 pi r. So for a semicircle, it's got to be 2 pi r divided by 2, so it's just pi times the radius. So in this case, this is just basically 4 pi. Well, now my perimeter in this case is 8 plus 5 plus 5, that's 18 plus 4 pi, and since we're dealing with centimeters, that right there is my exact answer. If you want to do the calculations with decimals, you can put them together, that's fine. But since they are not like terms, that's what we have to leave it as. So it's 18 plus 4 pi. So yeah, this part right here is 4 pi. That part right there on the arc here, that's 4 pi. That's the perimeter of that, or the distance from that arc over. We don't count the bottom 8 here because it's not actually attached to the shaded region. It's just showing us what we can do. All right, then we got another figure here. And it said again, find the perimeter of the shaded region. So we're looking for the perimeter from there, here, over, and we're just arcing all the way through this stuff. Now what you'll notice is that, again, it's a rectangle, and we have 4 and 2, which means down here we have another 4, and over here we have a 2. But what we don't know are these little quarter circles. Now, if you think about it, guys, it's 90, 90, 90, 90. Guys, if you add 4 90s together, how many degrees is that? It's 360. So, guys, 360 degrees is what? That's one circle. So, in all reality, I'm finding the circumference of one circle and adding it to my 4, my 2, my 4, and my 2. So, my perimeter, in this case, is 4 plus 2 plus 4 plus 2 plus the perimeter of one circle. So, in this case, 2 pi times my radius, in this case, is 3, so it's 6 pi. So when we add those together, that ends up being 12 plus 6 pi, and there's my answer. So don't think this is, oh, it's so hard because it's got those missing pieces, but if you realize it's a quarter circle plus a quarter circle plus a quarter circle plus a quarter circle. 4 quarters is one whole thing. All right, the next section is area of circles. So we just did perimeter, circumference, and arc length. Now we're doing area of circles and sectors. So if we remember, way back again, my area of my circle is pi times the radius squared. This is why I like dealing with radiuses more, because you just see it all the time. So it's pi r squared. So we're going to do for area pi r squared. Don't get it confused with circumference, which is 2 pi r. If you get those mixed up, it will cause a lot of pain. All right, so a couple examples here. We have, first one, we have my radius of 8 centimeters, and we want to find the area. So my area in this case is pi times 8 squared. In this case, 8 squared is 64. So we end up with 64 pi, and then we're dealing with centimeters squared. So when we write the units, guys, remember to write the unit squared. Since we're talking about an area, it has to be squared versus a length, which is like circumference, and that's just straight up. All right, the next one here. I give you the diameter is 2 2/3. Now, one of the better things to do with that would be convert that to a mix, an improper fraction. So 3 times 2 is 6, plus 2 is 8. So that ends up being 8/3. Now, that's my diameter. That's not my radius. My radius in this case would be 8/3, half of 8/3, which ends up being 4/3. That's my r. So that's what we're going to use for that one. So now we can do my area. Area equals pi times 4/3 squared. And I purposely do this one to give you fractions. 4/3 squared, that you do 4 squared, which is 16, over 3 squared, which is 9, times pi. And we're dealing in miles, so miles squared. So that would be my area right there. 16 pi over 9, or 69 pi's. All right. This last one here is, I give you the circumference is 4 pi, and I want the area. Well, first thing we need to find is, what's my radius? So we need to work the circumference one backwards. 2 pi r equals 4 pi, divide by 2 pi, and we see that r equals 2. And now we can do the area. Area equals pi times 2 squared, which is 4 pi, but in this case it's yards squared, not yards. So yeah, even though the circumference and the area look the same, that only works when it's 2, not any other numbers. All right. And then the last one here I give you is, I give you the area, I want the circumference. Now this one you do have to make sure your math is doing well. Area is 50 centimeters squared. So we know that 50 is equal to pi r squared. Well, we got to solve for r. So first thing we're going to do is divide by pi. So we get r squared equals 50 divided by pi. And we're going to take the square root of that. So r equals the square root of 50 over pi. And I'm going to leave it like that until I get my circumference, and then I will change it to simplify it. I mean, if you want to, you can simplify it right now, and maybe that's, we'll do that right now. We'll do that. So square root of 50 over pi, that is basically the square root of 50 over the square root of pi. If you remember from your algebra days, we can split that up. And then 50, take out 25 and 2, which ends up being 5 root 2, because 25, square root of 25 is over square root of pi. And then we got to rationalize. So we multiply both top and bottom by the square root of pi. And we get 5 times the square root of 2 pi over pi. So that's my radius. Now I can find my circumference by going 2 pi times 5 square root of 2 pi over pi. And what we'll see here is that my pi's cancel out, so I'm actually ending up with 10 times the square root of 2 pi. And since we are dealing in centimeters. And I know that looks really confusing, but you just got to remember how to do simplifying and all those other good things with that. All right. Sectors. So when we talked about arc length, I said it was a section or a piece or a portion of the circumference. Same thing with sectors. Sectors is a piece or a portion of the area of a circle. So think about it. I used the pizza example for the crust was like the perimeter and circumference. So at one slice, you had a piece of the crust. Now we're talking about the whole slice. So cheese, tomato, all that good stuff, the toppings if you had any on there. You'll notice that the formula looks very similar to that of an arc length, except instead of being circumference, we have my area formula, right? We have the area formula back there. So we see sector over the area of a circle is equal to the measure of the arc that we're looking at over 360. So the back half looks the same. The front half looks similar, except instead of using circumference, we use area. And that's the only difference between the formulas. So you're actually not having to memorize that much difference between them, other than if you're looking for arc length, you use circumference. If you're looking for sector, you're using area. Right? That's the big key to all this. All right, so a few examples here. Let's look at the first one here. We want you to find the area of the green sector. So they give us that the measure of this angle here is 70 degrees, which tells me that the measure of UV, arc UV, is also 70. Again, central angle, keep that in mind from previous lessons. So we can find the sector, so I'm going to just put sector over pi times the radius squared, so 8 squared, equals to 70 over 360. And I forgot to do this. Again, you can rearrange this if you really wanted to as sector is equal to the measure of arc AB over 360 times pi r squared. Same principle. Again, I'm going to use the proportion more than anything. So here we go. We got my sector over 64 pi equals, and I'm going to cancel out my 0, 7 over 36. And now I'm just going to solve for the sector. 64 pi on both sides. Let me get that out of the way. So my sector is equal to 7 times 64 pi over 36. Now I'm going to simplify before I multiply 7 times 64. That's a big number. I think it's easier to just kind of start going out. We know that 36 and 64, they're both divisible by 2 if you just want to go the easy route. So that gives me 18 and 32, and again, that's 9 and 16. And now I have 7, 16, and 9. None of those are cancelable at this point, so now I'm just going to multiply them together. So 7 times 16, 7 times 10 is 70. 6 times 7 is 42. 70 plus 42 is 112. So 112 pi over 9. And since we are dealing in centimeters, that would be centimeters squared. So there's my answer. Yeah, you're going to get fractions. Get used to them. Got to learn to love them. There are more fractions in the world than there are whole numbers. All right, the next one here is I give you the diameter is 10, and I'm asking for the area of the sector. So we need to know what's my arc measurement of that sector. Well, the measure of that arc has to be 360 minus 45, which is 315. And then my radius here has to be half of the diameter, so I know my R is 5. I can now find my sector. I'm going to change just to S or SEC over pi times 5 squared equals 315 over 360. Well, that's my sector over 25 pi equals 315 and 360. They're all divisible by 45. This is a little tough one to get, but that actually simplifies to 7 over 8. You can do 5 and then 9, and it'll still get you there, 9, whatever. All right, and now multiply both sides by 25 pi. And my sector is equal to 7 over 8 times 25 pi. So 7 times 25, that's 175 pi over 8. And since we are dealing in feet squared. And then I told you we're going to have more composite figures. So here we go, the last one here. Find the area of the shaded region. So now I got this big circle, and I have 2 smaller circles cut out of it. So think about it, guys. We need to find the area of the big and the area of the small. So I'm going to go area big circle, area small circle. And that's going to help us. Now, the big thing is we need the radius for both of them. Now, we know the radius of the small circles are 3. So area of each small circle is going to be pi times 3 squared. So that ends up being 9 pi. And since there are 2 of them, we know the total cutout area of that is 18 pi. What we don't know is what's the big one. Now, think about it, guys. If that's the center of my big circle, how far is it all the way across from there for 1 radius? Well, if the small one's 3, then the whole thing has to be, you guessed it, 6. So my area of my big one is pi times 6 squared. In this case, would be 36 pi. So we know we got 36 pi. And we're subtracting, or we're taking out these 2, so we're going to minus this, so we're going to subtract 18 pi. And we see that my total area of the shaded region, what's left over is 18 pi. And since we're dealing in centimeters squared. All right. Be prepared for that. This is your homework for the night, and I'll see you guys next class.